Alright guys, this is the Coda Gia and it's already past 11 tonight, it's time for Doom. So I've opened GitHub and I'm looking at id Software's Doom, and I have no specific plan what I'm going to do. I'm just going to start reading the code and see if I can come up with any interesting insights. So a little bit about me: I've been in game development for several years. I've been in developing computer graphics software. My main specialty is C++. So according to the breakdown of the languages, I'm going to be at home with this repo, and I've worked on some code bases which were pretty old, legacy. So I hope that some of my insights and some of my takes on the code are interesting to you. So let's C++, and here it is at long last. Yeah. The Doom source code is released for your non-profit use. Okay. Real Doom data, I don't have it, but I'm not going to run it, just going to read it. Many thanks to Bernd Kramier for taking the time to clean up the project and make sure that it actually works indeed. So I've done stuff like this, and it's not pleasant while everyone else is working on the next glorious and interesting thing. You are back supporting some old project, and you really feel like you're wasting your life, but you're not. And yeah, this might seem like a thankless job. So in order to compensate a little, thank you, Bernd, and thank you for your service. Projects tends to rot if you leave it alone for a few years. Yes, they do. And it takes effort for someone to deal with it again. Yeah. The bad news. Only compiles and runs on Linux. Well, yeah, since I promised that I won't compile it, this is not a big shock since I'm under Windows at the moment. We couldn't release the DOS code. Yeah, so I'm not under DOS. So this is kind of good. Alright, my own sound code. Okay, I don't know what happened to the board. Cool. Okay. This might be interesting. The code is still quite portable. Should be straightforward. I wrote this code a long time ago, and there are plenty of things that seem downright silly in retrospect. Okay, so we're not gonna laugh. Maybe using power coordinates for clipping comes to mind. Interesting how this works. But overall, it should still be a useful base to experiment and build on. Yeah, that's why we're here. The basic rendering concept: horizontal and vertical lines of constant z with fixed light shading per band was dead on, but the implementation could be improved dramatically from the original code if it were revisited. Alright, the rendering proceeded from walls to floors. Okay, so we'll check it. We'll get back here when I need more information. The movement and lines. Some project ideas. Ported to a favorite operating system. Yes, I know that it runs on microwaves and coffee machines and smartwatches. So probably this is already checked. Not sure if the guys knew this at that point. Add some rendering features. Transparency. Transparency and bump mapping and deferred shading and probably people already added those. Add some game features. Weapon jumping games with jumping are superior. Also swimming and gliding and server. Okay, internet game. Yeah, the internet is still a thing. Do a 3D accelerated version. Modern hardware. 3DFX. 4090. Yeah, those kind of things. I think I was still alive. I was already alive, and I caught the end of 3DFX. I think that I had some hardware back then, even. Okay. Have fun. Hey, hey, yeah, this is John Carmack. Okay, so it's almost 30 years old. All right, so yeah, it was uploaded a bit sooner. So yeah, that most likely there wasn't GitHub in 97. So let's see. Probably this was the README that we were reading. Here's the license. Okay, so since this is a old code base, there is no .git directory or Visual Studio Code directory. So I've downloaded the code, and this seems to be the network stuff, sound server. So the bulk of the code seems to be here. So I'm just going to start alphabetically and see what I can see. So the copyright distributed in the hope that it will be useful without any warranty. Okay. Fitness for a... without even the implied warranty or fitness for a particular purpose. So this sounds like this sounds like the disclaimer of South Park. So this code should not be used by anyone. Perhaps the automap code. What is this? That's the name of the file, version 1.4. Interesting. From 97, the hour, late at night, not so late. There is also the possibility to be early in the morning. What is this thing? It's... seems like every source file has it. Okay, let me split my view in two so that I could look at more code at the same time. Okay, so this is one thing that perhaps I'm going to learn about later, or perhaps maybe it's used by an external system. I don't know. STDO, all right, so the system includes with these brackets, and the own includes with quotes. Yep, go to definition works. This is a very rare thing for me. I'm used to working in code bases where go-to definition is completely broken, and even in the newest versions of Visual Studio, once the project gets a little heavier, it dies still. Access to the LFB, I don't know what LFB is. Perhaps I'm going to learn later. Or if the internet is still alive, I could even Google it. Okay, so defines. So yeah, nowadays people look down on defines, and it's a better practice to use constants. In this case, this is not a macro, so you depend on the preprocessor to replace it. So it creates more work for the preprocessor, but otherwise constants should be just as good for the general case if you don't have anything too specific in mind. Some colors, so yeah. Blues 256 minus something seems to be a pattern here, but not clear what it is. Perhaps maybe later we would learn. Maybe there is some reserved space for color palettes or something like this. Automap colors. Background black. Your range 0. Yeah, okay. FB, some keys. Doomdev.h. So this sounds like a header that should be included everywhere. Yeah, it looks one of the topmost headers because it includes only system stuff, none of the actual Doom source code. Internally used data structures for virtually everything. Okay, key definitions, lots of other stuff. Not too long, but yeah, perhaps this is included in many places. Doomdev.h. Let me search it like this. Yeah, a lot of includes. Okay, so one thing that since I'm used to working without go-to definition is that I'm just constantly doing Control Shift and F to find different identifiers, and yeah, I'm just doing this just in case, because yeah, sometimes the tools are not working. It's good to have tools, but if your tools are not working in your case, you gotta be able to survive without them. So yeah, I'm rarely depending on the tools working perfectly, because yeah, people make the tools, people write code, the code has bugs, so tools also have bugs, and sometimes it's better to know what to do, if to just have an alternative in case anything is broken, and don't rely just too much on anything, otherwise it might bite you. So yeah, I'm doing Control Shift and F, and actually it's a good practice to use a specific directory here instead of the entire solution. I've had colleagues suffer with this if, for example, you're looking for something, but it doesn't come up with this in the search. It doesn't seem to be used, or some of the search appearances are missing. And it turns out that, for example, it's in a file which is right there together with the other files, but it's not included in the solution for some reason. For example, it could be a header file, and the CPP files can include it because it's there, but it's just not added to the solution. So it compiles, but it's not searchable, for example, stuff like this. And when this happens, it really is a waste of time. So I just avoid it by searching in specific directories instead. So looking at Doom Dev, also one thing that I noticed is that the guy seems to be using header guards. I prefer Pragma ones. Header guards also have they could bite you when, for example, if you're creating a new source file. Sometimes colleagues just duplicate some existing file and then delete everything and start writing their new thing. And this saves you some effort, especially if you need to preserve comment headers like this one with disclaimers or stuff. But sometimes it happens that you forget to replace the header guards, and the problem is when things start to break that are not really obvious. It doesn't compile for some reason, but the compiler message doesn't say that your header guard duplicates with some other existing one, and it's sometimes hard to find what the problem is. So it's good to have some kind of convention. For example, here it seems that it's just the name of the header file preceded and appended with underscores. For example, some people add the date and even the hour and some random identifier, because also it's possible to, even if you don't duplicate manually the actual header file, you could come up with a header guard that just coincidentally coincides with some existing one, and yeah, this is really nasty as well. So I tend to use Pragma ones instead of this. Doom version 110. This should be 1.10, like here, I guess. Game mode, shareware. So it's good that it's not shovelware, and registered commercial, retail, and undetermined. Okay. Just plain, not really plain, like type deft with a name. They seem to be using the underscore T for types. Mission packs Doom and Doom 2, TNT, Plutonia. Okay. Several languages, so there seem to be localization, yeah. So, probably there are some identifiers saying which strings correspond to different messages and stuff appearing in the game. I wonder if this stuff is included actually in the GitHub. It said that some of the resources are missing, but maybe, not sure how you define resources. Maybe the resources are just the images and the audio and the models, but the language stuff sometimes fits in the code. Sometimes it's an external file. Depends on how they decided to implement it. If rain check is undefined, most parameter validation debugging code will not be compiled. Nice, there is parameter validation debugging code. How is it used? Define. Aha, it's manual. It's manual validation. Okay, so I thought that there was some kind of more automated system, but yeah, it seems that you just add this to the beginning of the function and add some validation, which is, yeah, that's cool. That's nice. It's some kind of testing. I never did this particular thing or saw something like this, but it seems to make sense. Just someone needs to, yeah, someone needs to support it and extend it when needed. External sound server. Okay, this one is commented out. Base width. Probably these are the pixels of the screen. Not used anywhere. Both uses are commented out. It is educational but futile to change the scaling to 2. Drawing of status bar menus is tied to the scale implied by the graphics. Interesting. So this seems to be something like the high DPI scaling that you would find in modern code. So I've had to deal with this kind of stuff. Interesting if it could be a floating point number or if it is just an integer. Does it still... Here's one place where it's used. ST height. Height of the status bar. Perhaps this is the bar at the lower part of the screen where you see your stuff. Now sensitive for scaling. Okay, cool. ST stuff. Perhaps ST is the status bar? Status bar code. Okay, so there are some prefixes which I have to learn. Inverse aspect ratio. This is below 1, so probably it's the height divided by the width. Not used. So yeah, if it was me, I would have probably removed that code. Define suck. Oh yeah, these are the moments of revelation. C sucks. C++ might suck for OOP, but it sure is a better C. Well, yeah, overall, I guess. So there. Okay, so yeah. I guess the code could work even without this comment, but it gives some insight into the feelings of people. And yeah, code is art, and yeah, frustration is a part of art as well. The maximum number of players, multiplayer networking, state updates, number of ticks. Shouldn't this contain K? TICK? These are the ticks per second of the engine, perhaps? 35 ticks per second. Power up durations, how many seconds till expirations? Okay, so this is something that lasts for 30 seconds, 60 seconds. If this is the number of ticks per second, so yeah, this is quite there don't seem to be two ways about it. Wonder why there are 35 frames per second. Is this like, why isn't it like 30 or 60, or I don't know, maybe 60 is too much for the hardware back then, but maybe perhaps 24 or 30. Why is the number specifically 35? Also wonder how the game functions, whether it uses a fixed number of ticks or does it use a variable like delta time, like dt, which you could often find in code which deals with physics and stuff like that. So the problem with that approach is that if you have some drop in frame rate, for example, something starts happening on the machine, it starts downloading something, or the antivirus software finds something, or whatever, just makes the duration of one step of your game or of your software in general longer, then it could cause the physics simulations or stuff that depend on the delta time to explode. So using a fixed step is a safer way, though it might, if your frame rate varies too much, it might cause some things to start slowing down and speeding up, which is also unpleasant, but at least it's more stable. So it seems that this game might be using a fixed frame rate, which is a fixed step rate, which is going to continue working with the same frequency, even if the game cannot run up to 35 ticks per frame. Or otherwise, yeah, the problem with this is that if your display, if your graphics hardware supports running with like 120 frames per second, this is going to make the game run like 4 times faster. So there might be some fail safes for this. We are yet to see. I remember that even when I was a kid, if you start running, and it was somewhere around 2000 when I was a kid the last time. So if you start running some old games, some of them didn't have like a protection against running on. They didn't consider the newer systems. So if you run an old game through an emulator or something, if you run an old DOS game, for example, like Doom, it used to run many times faster and it was really unplayable. So perhaps there is some failsafe that should handle this here, but we'll see. The current state of the game: level, intermission, whether we are playing or gazing at the intermission screen. Yeah. The game final animation. Is there only one final animation? Or a demo? Cool. Skill flags: easy, normal, hard, no nightmare. Deaf monsters do not react to sound. Here's the nightmare. Key cards: blue, yellow, red, blue skull, yellow skull, red skull. Number of cards. Okay, so yeah, perhaps this is the guard for the end of the enum. Not a guard, but the count of the number of elements. So this is useful if you want to iterate all of the elements of the enum, for example, in a for loop. Like this. Yeah. Or if you want to have an array with elements corresponding to each element of the enum. Okay, so I tend to use the same name, like the prefix here, and it in this case underscore count to denote the count of numbers. So here's the convention seems to be to use a name with all caps. Okay, the different types of weapons, so not a million weapons. BFG, motherfucker, yeah. Okay, so the different types of ammunition. Okay, missiles. Chainsaw. No ammo, yeah, okay. Cool. Yeah, so these are the different durations. Different keys. Okay, keys don't seem to be key codes, they're just the... Yeah, it says that these are the ASCII uppercased. Yeah, so this is one specific thing. For example, for me, my native language uses the Cyrillic alphabet, so I always handle the uppercase and the lowercase, and I also handle the key codes of the keys in my software, so that if I press, for example, the key M, it will work no matter if I use the if I have caps lock on, or if I have changed my keyboard to a different language. So this is a way to make it more flexible, more versatile, more robust. I would have commented out includes here Indianness. I have a couple of extensions in my Visual Studio. One of them is showing potential typos, and the other one is showing right here trailing white spaces. So just some little stuff that helps me personally. It's just helping keep the code a bit cleaner. Yeah, a lot of commented out code. Why is it commented out? I don't know. And here's the end of the file. Okay, so maybe it should have been nice to place a comment explaining why this stuff is disabled, but Does this header exist, for example? Yeah, it does. Maybe so. If I would guess, maybe it's removed because since this header gets included in quite a lot of other places, perhaps including more stuff in it would make the compilation slower. So maybe they just included those headers only in the places where they were needed. So this way you could reduce your build times. Just make sure that as few things are included in as few places, and even you could use forward declarations of classes and structures in order to move your includes from your headers to your CPPs, which would make your build times even better. But yeah, since I cannot build right now, I don't know if this whole thing builds in like 10 seconds or 10 minutes or god forbid 10 hours. So yeah. Okay, so I've sidetracked with this header quite a lot. Let's go back to where I was, to the first file in alphabetical order. Okay, AM map. So some defines some stuff. Fixed move. Are these fixed point numbers? Fixed point implementation. Okay, yeah. This file also has the thing. Could this mean like resource ID or something? It looks like a resource ID in any case. Is there any any definition of this? Okay, fixed point arithmetic fix. Yeah, so perhaps the Doom guys didn't work a spell checker on this code, but yeah, it shows a lot of false negatives as well, because yeah, most of the if you just copy some identifier and paste it in a comment, is going to mark it as a typo immediately, which it is not. Okay, so yeah, 16 fractional bits and 16 integer bits, it seems like. Type def, it's an int. Okay, so on this system, the int seems like it's 32 bits. I know that on some older systems, it's not always clear whether the int is 32 bits or it could be 16 bits. Thank God that today we know that integers are always 2 bits on the hardware that we run, at least on PCs. And yeah, and 64 bits are underscore int 64. So a few functions. Okay, multiplications is just multiplying the so maybe yeah, we're turning those 32-bit integers into 64 bits, multiplying them together and then shifting them back 16 bits. Okay, yeah, so you don't have to shift them to the left with 16 bits because of the conversion to 64, I guess. Yeah, you just have to shift them again to the right. Just shift them one to the right after the multiplication is complete. Okay, yeah, that's cool. Wonder what they use those for. Yeah, there are many use cases. Okay, cool. Maybe used because of performance. We'll see. Division of fixed point numbers. So if the first number shifted to the right by 14, so this almost obliterates the integer part of the number, is greater or equal to the... Okay, so if the magnitude of A is much larger than the magnitude of B, then return either the smallest possible integer or the largest possible integer. Oh, Doom type. So yeah, these are not min underscore int, or actually they were int underscore min and int underscore max, the ones from the standard library. So they made their own integers. But yeah, so this seems to be negative one, yeah, and this is the positive one. So there is a catch with the minimum and maximum integers and the minimum and maximum floating point, 32-bit floating point numbers, because here the minimum integer is the largest negative number, while the float min constant means the smallest possible floating point number close that is the closest to 0, I think. So yeah, it's different encoding for the two cases. So that's why it's a good idea to use STD numeric limits. STD not like sexually transmitted disease, although yeah, it's not cool when abbreviations coincide. So looking at the, so what is this? So it does an XOR of the two numbers. So perhaps, yeah, so it would take the leftmost bit, the sign bit, and if the signs are different, it's going to return a, yeah, so the result of the entire XOR operation is going to be negative when the sign bits differ. So if you have a positive A and negative B, or negative A and positive B, this is going to happen, and you're going to have to return the minimum integer, the negative, the big negative integer. Otherwise, the biggest positive integer. Okay, and yeah, otherwise, if one of the numbers is not much bigger than the other, go into the next function. Okay, some disabled code. So yeah, if you're new to coding, if you haven't seen many other code bases so far, this is one way to have some code disabled without completely removing it, and yeah, without commenting it out, which might screw up the formatting or something. But yeah, this might be one way to just leave some code committed in the source code repository, but just left out from the calculations. Wonder if this is just the slower version and this might be the optimized version. What does it do? So, aha, okay, yeah, so we just convert the two integers with their fractional parts. We just turn them into double precision floats, so into 32-bit precision floats. We divide them together, and then we multiply them by the this thing. So this is this a bit mask? Oh no, it's just one shifted by, so it's the first bit of the integer part. So it's 16 zeros and then a 1. So where was I? Yeah, so this is going to just convert those numbers into a double precision floating number, which, yeah, so this is already the number that is supposed to be the final result, like in the 16.16 convention, right somewhere, right here. But first we compare it to the largest possible integer in double format, so it's .0 without the f. If it's .0f, this is going to be a 32-bit floating point, just a float. So we compare it to the largest possible integer, the smallest possible integer, and throw an error. It doesn't actually throw. What does it do? So this one seems also like an important file, so I'm going to be checking it first as well. I system. So yeah, it takes the variable arguments and prints them right here. Yeah, so this is a way to make a function which is not a macro but an actual function which takes variable arguments. So this is usually done so that you could pass those arguments to some kind of print method. Flush std error and shut down demo recording. Check demo status. Quit netgame, shut down graphics, exit. Okay, yeah, so we kill the game if we encounter such an error. We don't try to gracefully exit from all of the nested methods that we are in already. We don't throw exceptions because, yeah, usually for games, exceptions are not getting thrown. So in the studio where I worked, the first job of everyone when new source code arrived was to just disable all of the exceptions, all of the runtime type information, just get rid of this. And this increased performance sometimes significantly, depending on the compiler, but usually it is helpful to get rid of that kind of stuff and handle it manually. And yeah, so also exceptions have other problems, but especially for high performance software, usually they are out of the code base because of their performance. So this is one thing that I have specific feelings about, this kind of formatting. So one thing that I would do in this kind of code is write it like this. So first off, the method that gets called after the condition is not tabulated like this. So it's just on the same line. I've seen throughout my lifetime several bugs where several cases where people suffered a lot. Perhaps I was one of those people. I don't actually remember correctly, so I am one with the matrix now, so I don't make a difference between me and other human beings, if you know what I mean. So, but yeah, people suffered with this in real life, and the situations that happened were like, so there was an if or for statement. Usually the bugs happen when it's an if, without any opening or closing braces. So first off, someone could write something like this, thinking that these are in the same block, but that line is not going to be executed only under the condition. It's going to always be executed, but because this is equivalent to this. But actually, the biggest problem that I've seen would be, for example, if this is a macro that does something. So, for example, like, let me just really define something as this thing with the semicolon, and yeah, for example, call it like this. Okay. So if I do this thing, when this condition gets satisfied, this method is going to be called. But imagine that someone does something like this. So if there is some kind of condition, define something as the method. Otherwise, define something as nothing. And if this condition fails, if this is not defined for some reason, then this thing becomes nothing. And then this condition starts affecting the next line of code where there is some expression. So it is going to effectively become this thing, and this is very nasty. Sometimes you see that the program is not working correctly, but there is no crashing, and it just does weird stuff. And just looking at the code, sometimes you cannot spot something like this because it looks normal. So especially if this is a macro, it could look just like a regular method, so you might not really notice it unless you really decide to step through the code, and if you even know where the code that creates the problem is. And yeah, it is especially worse when there is no indentation like it is right here. So this is one thing that I'm always careful with. So what I do is just that whenever I write an if statement or for or while, I always use braces, no matter if the code that gets executed is just a one-liner. So this really saves me some headaches in advance. And I found out that for myself, this is really useful for preventing stuff that just shouldn't have happened in the first place. Yeah, I know that it blows the code a little, it adds an extra line, so it's not that compact. You could see less code in one screen of space, but yeah, when you run some tool that tells you how many million lines of code you have in your code base, it's going to add something to it. So there are pros and there are cons to this, but yeah, I just find it safer to do it like this. Okay guys, so this video has taken already like 40 minutes, so I'm going to pause for now, and I'm going to continue looking at this code. If you have any other interesting code that you would like me to look at, please let me know, and I hope that you found some of the stuff that I was yapping about interesting. And thank you for staying here, and thank you for watching, and see you in the next episode. I was the Codagia.